Welcome to lesson 3.3, working with radicals part 2. So we're going to continue with some of the work we learned before and combine a lot of it together. So in 1a, we have two different radicals being one subtracted from the other. So I'm going to simplify my square roots first, and then I'm going to collect like terms, but this time it won't be like terms, and then I'll collect my like radicals. So let's see what we get for 1a. So root 75, I see that it has a 25 inside it. So I could write that as root 25 times 3. If I take out that root 25, it becomes a 5 root 3. So I'd have 5 root 3 minus 3 root 3. Because they have like radicands, because the guts match, I can just subtract the coefficients. So I get 2 root 3. Question B, simplify. Let's simplify all of them. So root 18, I can write as root 9. I'm going to show a different way. Root 9, root 2, because I don't have to have them underneath the same radical sign for them to be multiplied, plus 2 root 25 root 2. And then for the last one, I'm going to do minus root 100 root 2. And if I do this, the square root of 9 is just 3, so I get 3 root 2's. And then the square root of 2 stays out there. But then the square root of 25, when I take the square root of it, that's just going to be a 5. And then the root 2 stays in there, minus the square root of 100 is just 10 root 2. Whoops, that was supposed to be pink. So first we're going to have to do some BEDMAS here. I'm going to have to multiply those. So I'm going to have 3 root 2 plus 10 root 2 minus 10 root 2. They all have the same radicand, the same guts underneath the radical sign. So if I have 3 root 2 plus 10 root 2, that's 13. Take away 10 more, leaves me just with my 3 root 2. For question C. Okay, so if we break it down, I could write this as 5. 12, I'm going to write it as root 4 times root 3, plus 18, I'm going to write as root 9, root 2, minus 4. 75, I'm going to write as root 25, root 3, plus 2, and I can break 8 into a 4 and a 2. And I do all this because for all of these that are perfect squares, I can now write them outside the radical sign and maybe multiplied whatever else is there. So like this one, 5 to the 4, I can reach 5 times root 4, I can change that to 5 times 2, which ends up being, root 3, which ends up just being 10 root 3. Plus, root 9 is just 3 root 2. Minus 4 stays out front. When the 25 gets square rooted, it joins out front and it's going to be multiplied. So that's plus 3 root 2, and then that's going to be minus 20 root 3. And for the last one, the 2 was out front, times. When that pink square root of 4 is actually square rooted, we're going to get a 2 from that. So the square root of 4 is 2, and that's going to be times 2. And when I multiply together the 2 and the 2, I get 4 root 2. So if we look at these, we have 10 root 3, and then minus 20 root 3. And now I'm going to be collecting like radicands. So 10 root 3 minus 20 root 3, that's going to be minus 10 root 3's. Then I've got plus 3 root 2 plus 4 root 2. So these are like, they have like radicands, the guts match. So plus 3 plus 4 is going to give me plus 7 root 2. Question 2, simplify. Remember that something in brackets squared means write it out 2 times. So If we have the square root of bracket 3 root 5, I'm going to write it out twice. So 3 root 5 times 3 root 5. And we multiply outside times outside first, so I get 9. And then root 5 squared, I hope you remember from last lesson, that just equals 5 because the square and the square root undo each other. And the reason, so root 5 times root 5 is root 5 squared. That's how we got that. The answer on this one is going to be 45. There is a shortcut. The shortcut, or the trick, the shortcut is to distribute the exponent onto both the coefficient, that's that number out front, and onto the square root. So we're going to try the shortcut for b. We're going to take that squared and we're going to distribute it, so we'll get minus 2 squared, and then we'll have root 6 squared. Minus 2 squared is positive 4. Root 6 squared is just 6. So the answer is 24. So it's a pretty handy shortcut, but if you forget it, you can just write it out twice. For c, we've got two separate terms here. Minus root 4 to the 5 squared plus 6 root 3 squared. So I'm going to do minus 4 squared. I'm distributing that square onto both parts. And then I'd have root 5 squared. That would give me positive 16 times square and the square root undo each other, so 5. So 16 times 5 is 80. Plus, I'm going to distribute that squared again. So I get 6 squared root 3 squared, or 36 times 3. 36 times 3 is 108. And we add those together, we get 188. For question D, we're going to do the same thing, distribute up top the squared. So up top, we're going to get 8 squared root 2 squared, which would give me 64 times 2 up top. And then with below, I'm going to get 3 squared root 6 squared, which would give me 9 times 6. So we could cancel. I can see here, I would probably cancel 2 goes into 2 once, 2 goes into 6 3 times. And then up top, I would, in the numerator, have a 64. And in the denominator, 9 times 3, 27. And we'd be done. E. So E, we're going to do like 3 different distributes. We're going to distribute that 2. We're going to distribute that exponent of 2. And we're going to distribute in the denominator that exponent of 2. So we would get, up top, 2 squared root 7 squared minus 4 squared root 5 squared. That's my up top. And then down low, the denominator, I get 3 squared root 13 squared. So let's look at that numerator. 2 squared gives me 4 times root 7 squared gives me 7 minus 4 squared is 16. Root 5 squared is 5. 3 squared is 9, and root 13 squared is 13. So I got to do some bed massing. So 4 times 7 is 28, minus 16 times 5 is 80, all over 9 times 13 is 117, which gives us, calculator time, minus 52 divided by 117. So minus 52. 52 makes me think of 52 cards, and we got 4 decks of 13. So 52 is divisible by 13 and gives 4. 117, let's see, divisible by 13, it is. So if I divide that by 13. The numerator and the denominator, I would get minus 4 over 9. And that's the final answer. Moving on. The next one says 3. Simplify the following hint. Simplify inside the bracket first and then explain the exponent. So we will definitely follow the hint. So we're going to simplify the guts first. So if I have 3 root 2's plus 2 root 2's, that's going to be my guts. They have a common, it's the guts of the bracket, but inside the guts of the bracket, the guts of the square roots also match. So 3 root 2's plus 2 root 2's gives me 5 root 2's. That whole thing is squared. So I have 25 times root, let me show that in between step. So now we distribute that square. So that would be 5 squared, which is 25, times root 2 squared, which is just 2. Because remember, the exponent of 2 and the square root cancel each other out. So we would get 50 on that one. For the next one, 4 root 3's take away another root 3. So really, there's like a ghosty one inside here, right? Because even though it's not there, I'm going to have to subtract it. So inside my bracket, these two radicals have matching radicands, so I can just simplify those. So 4 root 3's take away 1 root 3 leaves me with 3 root 3's. It's still all squared. Distribute that square exponent of 2 onto them both. So we get 3 squared times root 3 squared, which is 9 times 3, which is 27. For C, take care of the guts first. I have minus, it's going to be a ghosty one, minus 1 root 5 plus 2 root 5 plus 7 root 5. So that leaves me with 8 root 5's squared. Distribute that exponent. So I get 64 times root 5 squared. The in-between step would be 8 squared, which is 64 times 5. And 64 times 5 is 320. D, we know we're going to have to simplify the brackets first, but the guts of the square roots don't match. So we're going to simplify each square root. So if we were to write out the steps, step 1 would be simplify each square root. Step 2 would be to collect like radicals. Step 3, once we've done that, would be to distribute the exponent. And step 4 would be to do whatever multiplying needs to be done. So let's follow those 4 steps here. So inside the bracket, root 75 I can write as root 25 root 3. Minus 12 I can write as root 4 root 3. That whole thing's still squared. I can do this because root 25 I'll now write as 5 root 3. And then that's going to be minus the square root of 4 is really just 2 root 3's. And lo and behold, the radicands match, or the guts of the square roots match. So 5 root 3's take away 2 root 3's leaves me with 3 root 3's. That whole thing is squared. Distribute my exponent. If you go straight to 9 times 3, that's fine. But if you still want to write, you can write 3 squared times root 3 squared, which gives us 9 times 3. So the answer is 27. For E, we just have 2 more to go. For E, we're going to simplify. We're going to go through those same steps, remember? So we're going to simplify each square root, collect like radicals, distribute and multiply. So we're going to simplify 48. Last unit, I reminded you that 48, you can write 48 as 16 times 3, and that's the best way to simplify it. So I'm going to open my bracket, root 16, root 3, minus 108. So 108, if I'm going through the perfect squares, so I had 100, nope. 81, nope. 64, nope. 49, nope. 36, I think so. So 108 divided by 36 is 3. So that's it. It's got a 36 in there. So I can write this as root 36 root 3. And that was because 108 was 36 times 3. Nice perfect square here. Different perfect square there. Oh, and that whole thing was still all squared. So I have 4 root 3s minus 6 root 3s. And because the radicands match, I can collect like radicals. So 4 root 3s take away 6 root 3s, leaves me with minus 2 root 3. That's all squared. Distribute the exponent, and we get minus 2 squared, which is 4, times root 3 squared, which is 3, for a final answer of 12. Last one. Okay. When I look at 112 right away, I'm not sure what it would simplify to. But if I look ahead to the square root of 700, I can for sure see 100 in there. So I can see that that is root 100 root 7. And then I'm going to see 175 has a 25 in it. So 175 divided by 25. It also has 7 of those. So root 25 root 7. So to me, it's looking like I need something that I'm going to see if 112 can be divided by 7. So 112 divided by 7, and it works, and it's nice. Not a coincidence. So root 16 root 7. I'm going to simplify all of those. So root 16 is 4 root 7s. 4 root 7s. Minus 100 is 10 root 7s. So 10 root 7s. Plus root 25 is 5. So I get 5 root 7s. They all have that base in the same radicand of root 7. So if I have 4 root 7s take away 10 root 7s, that's minus 6 root 7s plus 5 gives me, oh, this whole thing was still squared. Sorry about that. So that's minus 1 root 7 squared, which would be minus, oh, weird one, minus 1 squared times root 7 squared, or just 1 times 7, with a final answer of 7. Oh, hey, I can say I got 12 right and I got 7 right. Thank you for watching. See you in the next lesson.